Yes. Maybe. Time to stream. Time to stream time. Play my intro. Swag me out. Okay. So, let me open this. Creator dashboard. We got a bunch of new followers, dude. We got 1, 2, 3, 4 Nuevo Followerinos. Mega respect. How do we sound? Mega respect. I had a Reddit post. I had a freaking Reddit post pop off. I never popped off on Reddit like that.
Voices, words, dream,
Let's go look.
revolution, salvation, music, until
Distance, time, unconscious, dream,
Dude, we just hit some nice...
numbers, words, secret, chance, infinite, destiny,
destiny,
Oh, maybe it didn't pop off.
freedom, freedom,
Oh!
freedom forever, freedom,
Whose bench is that? Hey, look at these upvotes. Whose bench is that, dude? That's me.
voices, words,
Yeah, this was really cool. This was last stream's project.
energy, distance,
power, unconscious, infinite,
dream,
earth, heaven,
stars,
Never popped off even remotely like this in my life. So if you're new based on that, welcome. Welcome. You're gonna like it in here. The next year of projects are all related to Home Lab. Maybe even more than a year, maybe forever. I love this stuff. I'm really enjoying myself. Okay. Enough of the victory lap. We're here today to do PCB assembly.
music,
So there's a right way. Let me open this. There's a right way to do this, and there's a correct way, and there's the almost correct way, and then there's the bad way, and there's a lot of different ways to do PCB assembly, especially by hand. I have solder paste. I don't really like it. I just like the blade tip and the small tip and taking my time. Unfortunately, I wish I could get more skilled. Actually, what I really need, what I should invest in at this point is a hot plate. Let me see how much these cost. Yeah, they're kind of fucking expensive if you want a good one. It's so hard. It's Heiko, dude. Solder pot. Oh no, that's for dipping. Yikes. Crucible. That's for dipping. I don't need that. Actually, this is cheap as shit. 58 bones? Wait a sec. $850. That's not as much as the freaking GPUs. Excuse me. $198 ratings. What are people saying? No previous experience with SMD managed to make several boards over multiple without problem. Large power, smooth, even temp. Looks solid, but the manual is practically non-existent. Why would you? Not flat, not accurate temps. That's pretty bad. Yeah. I need one of these. And I need to get more comfortable with solder paste. But I'm an old man. I'm stuck in my ways. I'm stuck in my old man ways. And I like the blade tip, and I like hot air, and I like moving deliberately. This is actually kind of just a whole new chapter in the stream. Moving towards assembly of all this stuff. Everything's printed. There's a chance the PCB doesn't work. There's a pretty good chance that the PCB doesn't work. And we're going to have to order a V2 and be depressed. But there's a chance it does work. And now we've begun the whole assembly phase of the project. It's kind of exciting. So I think what I'm just going to do is just go low and slow on this assembly. I have everything here. I have a massive box of DigiKey stuff that's very unorganized. So what I need to do is kind of like unpack the box, find the components I need, put them on the board, and then put the remaining components in my component storage, like just as I go. And I think I'm going to go by region. So I think what I'm going to do is start with the voltage regulator, test that, make sure that works, and then do one channel of the MOSFETs, of the PWM, and then test that with the function generator, and then do like an LED, and then do a voltage divider, and just kind of go area by area, and then do like a bulk population. Just to make sure everything works, because this isn't like a design. This is a simple as hell design, but this isn't. I've never assembled even like components of these before. So that's the plan. That's the plan. Let's get into it. Pretty much, honestly. Okay, so let's. Check 1 2. How do we sound over here? Check 1 2. Check 1 2. Hello, hello, hello. Sounds pretty good. All right, so I haven't done this setup before. I've only used typically this screen here, which you can't see. Oh, you can see it up here. This screen is typically where I have the microscope, but I need to have the stream preview there. Or else I'm not gonna be able to like see what's on camera and what's not. So I have hot glued a little display here that has the microscope on it. So you're gonna be able to see that too when I cut to that. But I think first we gotta get the components. This thing is starting to warp. I keep heating this thing up way too much and it's warping, which is kind of annoying. Okay, so this bad Larry is my SMD parts that I have in stock. So I don't want to move that camera, but I'm gonna probably need to. This is how I do my SMD stuff. Not the best, but I don't really honestly work with SMD stuff that often. And I mean, at this point, I'm out of room in the studio. So I had to kind of collapse it as small as I could. So I think let's just go get the DigiKey stuff. Find what we're looking for. Actually, first, let me walk. There's like a, I showed it at the end of the last stream, but there's or whatever the, I'm gonna move this for now. Will I regret moving this camera? Probably. These are fans, don't need those. These are the huge fans, or these are the fans for the intake. I'm gonna move this stuff here. Damn, we gotta stay organized with this. This is a lot of stuff. So, here's the TVS diodes. Oh, I didn't update my stream title. Crap. Freaking whoops. Tools. Screen information. Okay, that's better. So I kind of showed this last time, but there is this plugin called Tools, External Plugins, Generate Interactive HTML Bomb. And it poops out an HTML file that has like the different components labeled. So the idea is like you can mark them as sourced in place. This is like an interactive to-do list for assembling your PCB, which is mad useful. So the first thing we need are C4, C5, U1, and F1. So C4, 10 UF, and 22 UF. 10 UF and 22 UF. So I'm going to leave everything. I'm going to get all the big stuff out of the box. I'm going to leave everything in the box. I think this is it. Yeah, this is it. Alright, so this is the regulator. Now we need the two caps. Fuse holder. Ooh, look at the fuse holder. I guess we need a fuse too. Here are the fuses. NUF, bang. Might be in my hand. Nope. 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 Looking and I'm not seeing it. Two UF and UF. Maybe I didn't order them because I might have them. MOSFET, resistor, TVS diode. Ah, bottom of the box. 22 UF. Jesus. Okay, so typically the best way to do this is to do the small parts first and the large parts later. But I'm going to violate that rule that I just said. I'm going to immediately violate the rule because I want to go section by section here. So we're going to do the two caps, and then we're going to do the regulator and the fuse. So we're going to do the two caps first. And the regulator. So I'm going to get this back over here. Fighting a vacuum underneath my feet. Okay. Not bad. So the reality of the situation is that the camera, the microscope is out on a huge arm. And so it's going to be a little wiggly jiggly. And that's just kind of how it is. Wait, let me get this mouse plugged in. Yet another mouse into my keyboard and my computer. Okay, so now let's get the components picked. So U4 is the 10UF1, 10 microfarad. Actually, no, before that, let's get the soldering iron plugged in. Eggs are a little scrambled right now. Just kind of slamming this first assembly stream. I think this might be 1 or 2 days of streams. I'm going to try the blade tip first. We're going to try the blade tip first. Just pour my drinking water into the soldering iron stand. No big deal. Okay. So, kind of the method that I've come up with that works is essentially, oh God, find the component, solder one of the pads, melt the pad while you slide it into place, and then solder the other pad. I saw a YouTube video about that technique, but I don't remember what video it was. I could honestly use, oh, that's pretty good. I was just going to say I could honestly use probably a whole new set of tweezers, but who's got the budge? I might... There's a lot of dead space on this camera. Maybe I'll switch that if it doesn't end up looking great. Let me try to pull better focus there too. That's pretty much as good as it gets. Okay. Nothing to it but to do it. Okay. Solder pad. So we want to do 1 UF first. So we're going to mark this one over here. Sourced. Oh. Missed. There we go. Sourced. Okay. Put a little solder on, then grab the other leg, or grab the component, heat the leg you just soldered, and then slide it into place. Yeah, it's the ground pad. Not very good. Getting warmed up. Alright, not bad. Alright, so let's do the other side. Nice, much better. I think I can clean that first one up a little bit too. Wow, that is a lot of thermal mass. It's that ground plane. Okay. Right. This is not flowing away cleanly. Let's try more. I'll let it heat all the way up. Damn, that looks cool though. I don't think I'm going to be happy with this no matter what I try. Good enough. Okay. So you are done. C10. Alright. Go mark this. Placed. Just check if that's actually on there. Yeah, it's on there. Alright, so now we got the other half. I believe this is the output. Cap. Mr. C5. What's the smaller pad? Definitely that left one. So let's start there. Kind of going to be tough. I didn't really leave myself a ton of room here. Oh, I had it. Fuck. Go. Good enough. So then we'll go in from the other side. Do the other half. Okay, why was that so much easier than the other side? This pad's still pretty big. Whatever. Not gonna think about it. Alright. So now the challenge of that big boy. I don't really know how to do this. This is a time where it'd be good to have some paste. I think I might put a bunch of flux underneath it. Maybe I do one of these and then just flood the other side. That would definitely be easy. So let's go for that. So I'm gonna solder in this pin, and then I'm gonna flood this area, this tab, with solder after that. So let's get that off of there. Oops. So same idea, where you do one pin and like make the others happen. You do one pin by like soldering it, flowing solder onto it, and then sliding it into place with molten solder. I want to make sure this tab is visible. Did I just fuck this corner up? No. Okay, so nice. So let's do the other leg now. Ooh, why is it not going onto the pad? Uh-oh. There we go. Did get some solder up onto the leg, which is an aesthetic problem only. I guess we can go through and reflow this one. Also just get solder all up that leg. Not great. Man, yeah, this is a lot of thermal mass. Or my soldering iron stinks. Could be a bit of both, honestly. Okay, that cleaned it up quite a bit. Let's try that again. This knife tip is supposed to be, I think, a little bit, perform a little bit better than it has been, but okay. So now let's try this tab. I'm going to flip the board completely around. And I am just going to chill with the iron on this. Actually, I'm going to put some flux on this. With my bad tweezers for this job. Okay. Those guys are for flux. So let's heat this up. Okay. Now on solder. Okay, boom. Alright, so now I don't know if I needed the flux there. Because now we have a fucking mess. So I'm gonna get some alcohol going. Not for drinking, for cleaning. We're gonna get this cleaned up a little bit. Got cleaners. I got a little bucket. Yeah, alcohol now. Okay. Get all of this crap off of there now. Yeah, I fucking hate flux, dude. I hate solder paste. I just want everything to be purely mechanical. I don't hate it. I'm just not skilled with it. This is not really my wheelhouse. I'm kind of an indoor cat with all this stuff. Kind of an electrical engineer. Or kind of a software guy. Masquerading in the physical arts. To be honest. I gotta get my heat gun to get some of these areas for sure. This one is still kind of clean. Get a small one. Here it goes. Okay, that's good enough for now. So now it's fuse holder time. Never worked with this component in my life. Actually, wait, let's mark you. Sourced, placed. Oh, my bin is leaking. That's never happened. That's a new one. LOL. Get this fuse holder. Man, this is going to be annoying. It's a pretty plastic case that I just think is probably going to melt. I think what I'll try to do is hold it into place with the tweezers. Maybe try tinning. Get some solder on the tip of the iron. And I think I'm going to hold it into place. So there's a bunch of solder on the iron. And I'm going to try just holding it, whoops, into place. It's good to know about this fuse holder. It's kind of sketch. I was pretty stoked about this part. I'm still stoked about this part. It's not over yet. Ugh. Ah. It seems in there. Looks okay. Oh, you can kind of work up along the side of the clip. Let's get this over here. Give it another friggin' shot. Oh, wow, okay. It's not immediately, the plastic is not immediately, oh, I smell plastic now. The plastic is not immediately vaporizing, which is refreshing. Okay, that worked. Sick. Let's put the fuse in. Uh, Oh, that's cool. That is cool, bros. It's a little fuse holder. So it's really pinching it on the sides, not the butts of it. Nice. I'm gonna see if that measures on the multimeter. It should be like nothing. Yeah, dead short. Continuity test. Dead short. Nice. Okay. So that is the input regulator. A little bit gross. Actually clean this up a bit. All of my alcohol has gone into the paper towel. Okay, so theoretically, how should I test this? Should we... I'm wondering how to test this. I think this header... Yeah, because that pad... That's... the output right there. So if we put this header in, and then what's that ground plane look like? Where am I? There it is. Yeah, so it's just right into the ground plane. So if we plug 2 leads, if we plug 3 leads into this, put it into a breadboard, we should see if it works, which would be hype. Do I want to divert to do that right now, or do I want to continue soldering? I think I'm going to divert, because if that doesn't work, we got to kind of call an audible on the design as a whole. So let's do that. I'm going to go get a 3-pin header. BRB. Back with my drawer of male headers. See, oh look, a 3-pin. It looks so huge against all the other components. Okay. I'm gonna do it vertically like this, which is gonna require a little bit of fancy footwork putting it in place. I think I'm just gonna tin the iron, pinch it, and then solder the one I'm not touching. I could get that fancy dip machine we were looking at earlier, but not now. Alright, yeah, filming this is gonna be tough. So the idea, see the header wiggling around? So I'm just gonna hold it in place with my fingernail. And then I'm holding this square pin, I'm holding the ground pin, and I'm just gonna solder this one in place. And then put it in the vise and finish the job. Alright, so we got the tip loaded up. Oh. What? It's not that much thermal mass at all. Why is it not instantly reflowing? Alright. Good enough. Damn, that did not really go to plan. Whatever. I don't know. Dude, my soldering iron might be busted. Like I watch... Uh-oh, I didn't put the fuse back in the fuse bag. Like I watch, I've been watching a ton of Mend It Mark on YouTube before I go to bed. When I throw on mad Mend It Mark videos. His whole setup is so much faster than mine. I think he just has secret British guy soldering iron that's unavailable to the Yanks. Like, I feel like that should have flowed really quick. This ground one makes sense that it would take a lot more energy to reflow, but because it's a huge ground plane. Gross, but it'll clean it up. I just wasn't touching the board. Trick of perspective. I definitely just wasn't touching the pad. Okay. Sorry for the out of focus. Ugh. The center one. Get back. No! Uh-oh. We dripped on the mounting pad. Alright, I'm gonna try to get this off with tweezers. Oh, that's such an L. Actually, it doesn't really matter, because this is on the underside of the board. No, bro! Fuck. Alright, we're gonna leave that. That's a later me's problem. See, this is what I get for trying to check as I go. That's funny. I don't even know why the KiCad default is to have them plated. It's whatever though. Bang. Let's try to clean this one up too. Yeah, actually is just so much copper under there that I really have to get this hot. All right. Hit this with a little bit of alcohol. Hell are you doing, bro? Okay. All right, so now we test. So I think I'm going to switch the lens for this camera, for the microscope. So bear with me. Put this back in place. You're gonna see, all right, quick. It's a CMOS camera with no lens. What color is the image going to be? It's gonna be red. I don't really know why it's gonna be red. All right. New lens in place. Very shiny. Okay. All right, so let's go grip up a breadboard real quick. This will do. The old in progress project board. Okay, so we're gonna do DuPont wires. So let me close out this lens a little bit so you get more depth of field. Depth of field. Okay, cool. So ground, we're going to do right here. I always forget in power supplies, I think yellow is usually 12 volts. So that's our input. And then maybe 5 is red? Whatever, that's what we're going to do today. So I'm going to set up my DC load to just draw like 100 milliamp from the output. So the 5 volt pin. This is very funny. You have a much better view of this than I do, chat. So we're gonna do, you can't really see it. Yeah, imagine. I'm actually gonna turn the iron off for a sec to not singe myself. Grab my longest wire. So we're going to do a hill. Okay, so this is the DC load. The electronic load, so we can just program how much we want this to draw. Move this over a bit. Then we have the ground of the electronic load, which we are going to put here. So you also have to put the supply ground there. Then we have fresh fish sandwich in the building. Fresh fish sandwich. Yeah, we're testing the scary part, or not the scary part. We're testing the regulator to make sure that it regulates. Okay, so now this is the input. So wait, this is the supply. You can't really see this, but supply ground here. Let's find that that's off a pin. We're going to turn the DC load on. We're going to do current mode, 0.1 amps. And we're going to see what the output does. So I'm going to bring the voltage of the input up slowly. Start at 2. Already. Not. Output is 0.5 volts. Bring the input up. Nice. Okay, so the output is, let me show you. Ugh, can't see shit. So, let me get something to jam in there. Okay, so we do the ground pin here, and then we start probing around. Wait, we want to do DC mode. So I'm grounded there. Let's start probing around. 5 volts on the output. Five volts, bang the fuck on. All right, so that's drawing 100 milliamps. So this should be 12. Yep, so that's the input. The other half of the input's also 12. You actually couldn't see that. I'll show you there's the 5 volt output. Kind of moving around a little bit more than I would like. Maybe it's because of the low output current. That's fine. All right, so I'm going to increase the load to 500 current, 500 milliamps. Okay, so you heard my power supply click because it was in current mode. So now we're drawing 0.5 amp out of the regulator. So let's probe the output again. 4.97. 4.96. Interesting that my supply is reading 12. Trust my meter more than the display on my supply. It's kind of moving around a bit though. I wonder what our heat looks like. Let's fire up the thermal camera. Half an amp is, I think, way more than we're ever gonna need. Just do a quick one with this. 50C, 54C. System is initializing. It's pretty warm. Whoa, max 100C. That's pretty hot. Okay, so I'm gonna definitely more than it's pretty warm. Okay. But that works. Regulator is regulating. Regulator is regulating. It's regularly regulating regular. So, cool. So that's definitely going to be able to power the BeagleBone. Nice. I was pretty skeeved about that. The fuse is also fine. It's a little warm. It's a little warm. We're gonna keep going. We're gonna keep going. I think I could probably get a bigger regulator if I needed, but makes the voltage we want. Cool. All right, so let's get back to assembly. Nice. Okay, so I'm gonna do the next thing I'll do is maybe not. Part of me's like, let's do one channel. Okay, let me just turn all this off. Part of me's like, okay, maybe I do one channel of the MOSFETs. Test it. And then keep assembling. But I'm pretty confident in the circuit. I've actually never used that part though. Oh, dude, I got hit with spam, bro. I got hit with spam right now. What the hell? Get the fuck out of here. First time chat, last time chat. I don't know how to ban bro. No. Manage suspicious user. Restrict. Block. Block. Goodbye. I am not spam. No, you're beautiful fresh fish sandwich. You're the #1 fresh fish sandwich on Twitch.tv. You're the only fresh fish sandwich on Twitch.tv, actually. I'm kind of honestly, bros. I'm kind of skeezed at how hot that thing was getting. But fuck it, we ball. We're gonna continue. Fuck it, we ball. The bench is already a bit cluttered. All right, so I'm gonna switch. Ooh, I'm gonna switch lenses. Back to the microscope. Back to the microscope. Yeah, wait, fresh for a sandwich, you're gonna like this. Install our lens. It's not threading for some reason. We got microscope view, baby. Look at this. Beautiful copper pads. Beautiful copper pads. The pores are so good. Oshpak, exceptional manufacturing quality. Open rack vent. Nothing, not that website yet. Alright, so let's keep it pushing. Let's do one of the MOSFET channels next. Do we just stay over here? I think we do. Yeah, okay, so what I'll do zoom in more. More zoom. I don't know if I can. Alright, we're at max zoom now. It's dark in here. I have to pick it up by hand. Wow, look at the copper pads. Where even am I right now? It's the big V. So logic. Dot. Alright, so what I'll do, I've decided what we're gonna do. We're gonna do one of the MOSFET channels, one of the outputs, all three components in one shot, and then we're gonna do, if that works, we're just gonna do each of the rest of the whole board by component instead of by like circuit. So it'll be like all the resistors, all the diodes, all the MOSFETs. But this first one we'll stand this up, test it, and then go from there. Damn, it's only 7:30? Or it's only 8 o'clock? How's that even fucking possible? Bro, time flies. Time flies when you're soldering. Okay. You get this out of here. Move this. Actually, rather, time doesn't fly. It's kind of... I feel like I'm not skilled enough to be moving this quickly, but whatever. Let's keep the bench clean, though. Bench has been clean so far. Okay. Soldering iron back on. I'm gonna do exactly what I did with the other tabbed package with the MOSFET one. And just do one of the little legs and then the big ones. So these 4 bags. Oh wait, we didn't update. Okay. So F1 is done. Where are you? You're placed. Sourced and placed. You are sourced and placed. You're good. You're good. Oh! Yeah, okay. So now these ones. Q1 or Q2. Q2 D1 R9. Okay. So let me get the box. The DigiKey part number, so it's the MOSFET. There's only one MOSFET in the box. This boy. Put it on the microscope. And then it is the 10K ohm resistor. Diode. No, not the diode. Putting the diode back. Putting the diode back, not the diode. Okay. Nope. Is it in my hand? Oh, it's in my hand. 10K ohm resistor. Oh, it's the flyback diodes, not the TVS diodes. So it is a diode. Not the TVS diode. It's the flyback diodes. Actually, I didn't order those because I have an ass load of those, I think. Unless I did. And now I have an ass load plus. I did. Oh no, I got the same parts twice. Okay. Thank you, DigiKey. Yeah, so these I already have the diode. Okie dokie. So it's in the binder. Diode page. And pass load. Oh, struggling with diode paper. Okay. So let's do the MOSFET first. Welcome to my MOSFET unboxing. That's it. End of unboxing. Okay. There's the part. The plan is do like we did the regulator and put one leg in place. Get a little fucking less glare going on. Nice. So plan is do one of the legs. Do this. Do that top left. Do that pin number 1. And then do the rest of the pads. Trying to move stuff with my finger. I'm not going to try to move stuff with my finger. Oh, we gotta go back. That doesn't look very good. Yeah, see, this is what I was expecting to happen on the back of the board before. Immediate attachment and flow. Okay, nice. Come on now. Get off the tip, solder. You can do it. Yeah. Again, I'm soldering the legs. It's okay. This is very small stuff. Alright, so I'm going to flip the board. Or rotate the board, rather. I'm lost. There it is.
The people come together. It makes it feel good.
That's a pretty big copper pad. Oh yeah, look how it's resisting.
No destroying. It's the music that moves your heart.
Alright, boom. Actually looks fine up close, but looks kind of whack from afar. Get some more energy into this. Ah. Actually looks pretty good now. Okay, cool. You are in place. So let's do, while we're angled like this, let's do the diode and resistor. Oh, open the resistor. Didn't mean to do that. Let's do the diode. These are a little tricky, bro. That little thin ass line, you see it? That's all you get for orientation info. Okay. I'm gonna tin the tip of the iron. Because these guys are a little weird. Package is like up off of the board a little bit more than a resistor. Nice. Get that. Okay, good enough. Gonna be honest with you. Gonna be a lot of that today. Gonna be a lot of good enoughs. This is tiny stuff that is barely perceivable, and we are putting a microscope on it. So a lot of stuff is gonna look crazy, when in reality, it is not even perceivable. Resistor. Now we talking small, bro. Alright, we're gonna use the slide technique here. Bang. Boom. See, this is why it's awesome when you just have a tiny little trace. Ooh, God. I might have to take the hat off. I keep hitting the microscope with the brim of the spam hat. But the tiny traces, it's just barely, it's thermally, it's like, hello, who? What? Immediately, solder melts, which is very desirable. Oh, I just hit it. I just bumped it. Okay. Now let's flip the board and finish those two parts. So then we're going to try pumping some PWM into this thing. We're going to clean it, duh, because it looks crazy right now. But then we're going to put some PWM into this thing and see what the output looks like. Nice. Oh, I melted the package. Oh no, that's just flux. It's just flux. We're chilling. Okay. Clean that up a little bit. Where are you? Where are you? There you are. Yeah, the thicker copper traces. They just don't want to. They don't want to be nice, flowing, beautiful pads. Okay, nice. All right, so let's quickly clean this, as to just be very paranoid that it's not shorting. And then we're gonna hotwire PWM into it. We're gonna hotwire PWM into it to see if we can spin a fan. Dude, these little thingies are not that good, bro. I bought so many of them. They were so cheap. This is why they were cheap. They're falling apart. All right. I don't love that leg on the right there, so I'm going to touch that up. Okay, bang. Okay, so what is the best way to actually test this? So we have the PWM going in here. This is coming from this pin. Could do that pin. Could solder something onto here. I think we just put a single jumper right there. Or, you know what I have? Let's see if that'll fit. I have test points. I have mechanical test points. Let me try to put one of these in. Okay. This guy. Oh! Are you kidding me? Are you kidding me? Oh my god. Oh, we are fucking made in the goddamn shade. So that's like springy. I guess I could solder it in, but I don't think I'm going to. So now I can hook a lead off that. And I think maybe I could even do the outputs. So wait, let's trace this through. So trace, trace, trace. Goes over there. Blah, blah, blah. And then it's these two. So PWM NMOS 1 PN. Doesn't really. I mean, it might work. Let me actually stretch it open a little bit. Okay. So I stretched it out a bit, the two claws. So we're gonna go like... Yeah, this is gonna work. Great. So I can do... Fuck yeah. So what I'll do is I'll do... Oh, but we need to do a ground as well. So we need to have one all the way... Actually, no, it's got to be in minus. So it's over here too. This one. So this is This guy, yeah, this guy becomes the ground plane. Okay, so but these are little tiny thin pieces of sheet metal, or just like sheet stock that they've folded, so they can support very little current. That's really not what we care about. Alright, so this is going to be really hard to show. So I think what I will do is move quickly and switch to the wide angle. Greetings from wide angle land. So what we're going to do is put the ooh, I could do this. We're going to put this is so funny. Put the PWM in there with the off-camera function generator. We want to get a little fan to hook this up to test it, I think. Don't have a little one, but I do have an entire partially assembled module. So I think we're going to be testing our little clips, but that's okay. Actually, so we don't need this -1. We just need so this is going to go directly to the power supply. So this is that. This guy's going directly. Actually, I'm going to make this the black one so I don't lose my mind. So the path to ground is through our board. Positive is going right to the power supply. And then we have to also drop all my leads off the wall. We have to connect the other side of the supply to in minus. I'm going to switch lenses. Even though you can't super see what's going on, figure it's better than nothing. Okay, this is actually usable. Okay, so we're testing we've stood up one of the NMOS channels on the assembled PCB, and now we just want to see if it works, if it can rotate the fans. So I'm going to manually feed in the 3.3 volt PWM, and we're going to see how it interacts with the MOSFET. So normally this would be obviously provided by the BeagleBone, but in this case we're just doing it manually. So let's get it poppin', fellows. All right, so what I'll do, I need banana clips. So we're going to use one of these joints to go out from the function generator, into that probe. So I need another BNC to banana, or banana to alligator? This is all very funny words. Banana, alligator, come on now. Why is EE like this? Okay, so this is... I'm actually also going to probe this at the scope. My freaking drawers got stuck. I'm sorry. All right, I'm back. My drawers got stuck. All right, so we're gonna use this guy to be able to look at the function generator output. Take one of these. To channel 1 of the scope. Power in the scope on. Okay, so now let's... Oh! I turned the screen off. Check 1, 2. We're still chilling. Okay. Scope's going. Duty cycle dutying. Oh, wave square. What? All right, so we got a 28 volts. Okay, that's wrong. Oh, wait, because the scope's in 10x mode. And 1 probe 1x. Okay, nice. So amplitude is 3.3 volts, offset 100%, duty side 56%. Okay, so let me go to offset. Duty cycle is the thing I want to change. Okay, so this should be working. So I'm going to get another probe. Get another probe, and I'm going to manually poke around just to make sure everything looks the way we think it's going to look. I apologize for the 25 things going on at once, but we gaming tonight. Okay, so wait, we got to connect the grounds. Need more alligator clips. Okay, so we got all right, so let's look to see nice. Scope is still in 10x. That's right, actually. Okay, this should be working. So limit mode. Not working. This is the output. Hmm. This spin if there's nothing attached. Let's try that. Disconnecting everything. So it's not spinning. Okay, nice. So it's something with my connection. So the green wire, definitely that. think this happened last time. One of these croc clips might be broken. It is. It's time to destroy. Do no croc clips and just touch thing to the power supply. Here we go. That worked. You. That's working. It's a green guy. This is fucking green croc clip. It's busted. Get out of here. It's so annoying. Okay. Yeah, boom. So now we know that that works. So let's keep the positive plugged into the power supply and then have in minus he's getting the shortcut through the MOSFET. She back out. Oh. There we go. Why is this one not spinning? Alright, so we got rotating fans, kinda. That's working, but it's very slow. I think the frequency is really 40 kilohertz, so it's basically. Not really working like I wanted it to. Could it be? Could be a couple things. So it's kind of working, it's kind of not working. We're doing low side switching. We need a capacitor across. Yeah, these fans are trying to spin, but they're not. Hmm. So instead of this, go to the MOS, if I just do. Oh, what the fuck am I doing here? This is the wrong. Wait, how is that even happening? There was no. Oh, it might have been grounding through the scope. Okay, that's a whoops moment. Okay, so you're going here, and then you're going here. Okay, so happy to spin when connected directly to the scope. So we're going to put the scope ground up here, or the power supply ground up here. Is it that pull down resistor? So I'm looking at the waveform, and it looks like it might be related to the pull down resistor. This is officially a fucking. The stream has been upgraded to a debug stream, dude. We're debugging it right now. So why is it? Okay, so double checking my connections. So now it's doing nothing. But if I actually do not think these are connected internally, I can actually check. With the multimeter. Yeah. Okay, so let's do power supply ground. It's up here. And then we'll do it wants to do something that you start to spin. Maybe the pull down, honestly. So let's turn everything off and let me take the pull down out. Okay, everything's disconnected. I'm just going to yank this pull down resistor out of there. Hopefully not melting anything on the way. Okay. Hurting the board, stop. Okay, goodbye pull down. So plug everything back in. Still off. I can't even see square wave on the scope. Doesn't seem right. Where's the waveform, bro? I'm now very confused. Oh, I plugged it into the wrong side. Okay, now we're back. Jesus Christ. Okay, so now... Genius alert. Okay, now we got the square wave coming out. Go really fast. It's disconnected to this, obviously not going to work. Okay, this is not working again. Damn, I need new everything. Oh, this is a debug stream. This is a debug stream, fellows. I need new gear. Hopefully we're chilling. Everything's fine. Okay. This, we're just gonna try powering it from the supply again, which is now no longer working. Interesting, interesting. Okay, there we go. Boom. Powering it from the supply, no problems. So now we will try. So you are gonna go over here. Actually, I'm just gonna plug this into this pin. That's the ground, and then so it takes a sec for the fans to come on. Like when I might not be able to use the low side switching here. Damn. I did test this though. Earlier in the process. Huh. Okay, let's see what that looks like. Why does it look fucking crazy? I think it's because it's too fast. Hmm. Are the fans just not gonna work with low side switching? That would be a bummer. Mm-hmm. So now not working, period. Interesting. Okay, so I don't understand what is happening, and I don't understand why what is happening is happening. We are in the woods. Okay, so there's a very good chance that the fans are smarter than I thought they were, and are just deciding to not turn on because of the unstable ground or something like this. There might be something in there that's like preventing them from powering on, which would be a cool feature if it wasn't really bad for the project. Which would be a cool feature if it was not bad news. But now I can't get it to turn on, period. Okay, so... Just plug these right into it. The crock clips again. Other clips strikes again. Get wider here. Actually, let me just switch back to the wide completely. Because we debugging. We debugging right now, boys. This is a gnarly one. So what's happening is that I'm getting, in all cases, through the NMOS or not, I'm getting the intermittently able to switch on and off. To turn the fans on and off, basically, is what's happening. So, we grounded there. Ground. So now the function generator is for sure grounded. Ground the board like that. Okay, so now that's all good. I should be able to touch this to this and should power the fans on. That doesn't happen. So what's going on here? If I just do this, okay, that works. Okay, so this is also busted. That works. Okay, why was it partially working earlier? Let's think why that could happen. Okay, interesting. I increased the amplitude. This is interesting but bad. Okay, we have something. I increased the amplitude on the scope to 8.3 volts. And it started to work. So let me change the duty cycle. So it might be the MOSFET doesn't want to turn on. What does the output look like though, I wonder? Okay, interesting. So it seems like the gate voltage of this MOSFET is too high. Like the on voltage is too high. So we can double check this. So now these are working. I knew I checked this. So it's at 10 volts. Yeah, and I can vary the duty cycle and it changes the speed. Damn it. Okay, well, I guess this is good. Just means we're going shopping. Okay, let's go look at the data sheet. We figured it out. So it's the this part. Oh my god, it's right here. What? How? Ah. I must have ordered the wrong part. Ugh. Alright, so we got a shop for another part. RDS on. Damn. Okay, that's fine. I'm glad it is. I'm glad it is not the layout. The MOSFET's just not turning on. Oh, fuck. $1 a piece? Damn. Hmm. So I guess I'm still kind of confused why this didn't work. So max RDS on. So the drain to source difference. The drain to source, it's still. Hmm. Wonder what the. There's the N channel. The classic. What is the classic? This guy. This guy. Part of me is like, maybe I should just bang the beagle bone in there. It could be because the gate voltage of the part that we have this is less than we're seeing experimentally. It could be the function generator. So I think what I'm going to try is the beagle bone. We're going to try the beagle bone. We're going to try the beagle bone. Where's this drive voltage parameter? Okay. So it's this drive voltage thing. So it's barely conducting, and that's why we're getting the squeaks. So we need a different MOSFET. Okay. So, honestly, part of me's like, should we keep going with the rest of the assembly? I guess we wanted to do the MOSFETs last anyways. First, let's just find a new part. So... Yes, fresh fruit sandwiches, frown. I did frown. Frowned it. I misread the data sheet. I actually misunderstood how MOSFETs work. I forgot, which is kind of embarrassing, but here we are. So, what is the fan that we're using? We are using and you also forgot. Yeah, that's right. You guys watched me do it, so that's just how it go. I can't find the part number of the fan. We gotta go to the CAD model. What are you called, Mr. Fan? Ah, yes, of course. How could I forget? The... Oops. 08015SS12N AT00. How could I forget? So we need at least 600 milliamps. That's very funny. So we have one part that is acceptable. It's kind of expensive, $1.18 each. 2.5 was specified. Right, house density DMOS. Yeah. Alright, so I gotta cop me some of these. Okay, luckily it has the same footprint. Okay, so why is it saying the max VGS is 1 volt, but RDS on at VGS 2.5? You know what I'm saying? Okay. Yeah, this will definitely work. So that's like, this is barely on. This is the number we care about. Okay, so I'm gonna write this part number down. And I think we're gonna continue soldering, because I still got some gumption in me, but I might take a quick break. Get some more water. Let me write this in my notes for today. And then I'm going to continue, I'm going to do all the diodes, and I'm going to just keep, I'm going to clean up, and then I'm going to plow through as much of the other passives, etc., as I can. Yeah, so I will BRB. All right, we back at it. God damn. That was some debugging, bro. Look at this. I gotta take a picture of this. We debugging. So the MOSFET is not turning on at 3.3 volts. That's the problem. No card and camera. Which is extremely easy to fix. And is thankfully doesn't mean I have to, it means I don't have to means I don't have to redo the board. Really didn't want to touch the board. I wonder how I should version that though. I guess I haven't published this yet, so it hasn't gone anywhere. But that's interesting. So it's just the BOM that's messed up. The design is fine, but the bill of materials is wrong. I wonder what kind of error that is. Did you cut a new version for that? Software, it's easy, because even if it exists anywhere, you gotta cut a new version. But this never was made. Interesting. Okay. Pictures taken. All right, let's clean up here. This is crazy. This can go away. Fan can completely go away. This is off. I gotta get all new. My whole probing setup is no good. Probably. I mean, doesn't seem like it right now, but we're getting close to being done completely with this whole project. Actually, maybe it does seem like we're getting close. But I'm probably going to reorient things a little bit. I think generally the studio here has held up pretty well to the streams, especially the design ones. And that's really not saying much because a lot of the design ones are purely software. Like there's no physical element to the design streams other than just talking. So I think largely the studio has held up okay to this series of streams, but I think I'm definitely learning a lot today with the equipment that I want or the stuff that I need to be able to do this correctly. Like it would be great to be able to have the scope and the function generator visible to you guys easily. But then I'm like, okay, well, then I have like 20 fucking camera angles going, and that's pretty hard to see what's going on. I guess it is what's going on though. My goal here with the streams Just like the blog, just like everything else. Maybe not so much the blog lately. I'm a little less honest on the blog than I could be. Just it's more of a this is the result kind of a thing, not necessarily this is the process. That's what I think. I think maybe that's the creative thesis around the streams is like purely the process part of the process. Purely the tough parts of the process. I really haven't touched this project whatsoever not live on Twitch, which I kind of did that. No, that's not true. The first version of the cooler I didn't touch at all offline, and that's, I don't know, that's interesting. I'd like to think you could only get it or it's harder to come by, but I really am not looking for it personally, which is probably a problem, but I don't know. These are supposed to be honest about the process. Or at least as honest as I can get. So I'm just trying to tidy the workspace a bit. Gather trash. Put away stuff I'm not using. It would have been nice on this board to have just like a corner of it. It was a ground pad. I kind of knew going into this that there was going to be bumps. I haven't like done an SMD design, anything that isn't like a perf board in quite a while now, so I was like, yeah, this is probably going to have some bumps. And I tried to, I mean, the pin header, the power pin header was useful, you know? Okay. We're pretty much stood back up. I am going to reattach the microscope lens. The working distance of the microscope's pretty good, but this microscope's setup at this point is mad DIY and could definitely be refined. I don't know, chat, is there anything? How do you think the session is going? Camera shaky, blah 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 blah. Audio should be okay. I have my own mic for this desk. This should be okay. Alright, microscope is back. This is back. Were these the NMOSs? Yes, they are. These are good parts. It's not for this design. Audio and camera both great. Awesome. Yeah, it's going to be an iterative process getting this right. Definitely am more of a talk myself out of it person rather than talk myself into stuff like this. Just kind of sending it and seeing what happens most of the time, but okay, let's get back to it. First, let's get this MOSFET off. This is actually going to be a challenge. I think I'm going to go for some braid. See better, probably could see better than you when you were soldering. Yeah. Well, I have this little display here that sees exactly what you see. This little monitor. Because yeah, I definitely wouldn't be able to do this stuff if I was eyeballing it, but so it's not all crazy. All right, so we got to extract this part and we got to put that resistor back. So this stuff is thin copper wire that is braided to kind of soak up molten solder. Because the idea is the solder is going to wick onto the copper and stay there. And I used it a couple times over the years. Well, this is my first roll, so I'm not using it absolutely all the time. And it works okay. Alright, so we're definitely getting some off here. Might actually be better to heat gun this off, but I'm going to try to get as much of the solder off as I can. Just try to make that process a little easier. All right, so let's get the heat gun going. Okay. Old faithful heat gun. Cheap and cheerful is the best way to describe this heat gun. Just kind of want to avoid the plastic on the board, basically the fuse holder. Nice. And I didn't take any pads with me. Okay, good riddance. am unspooling my vise, and I'm going to just leave unscrewing, spooling. I'm going to just leave it in the vise. Leave key gun in the vise. So now we can clean those pads up. So the next time I gotta get in there, it's a little bit easier. Hopefully with the correct MOSFET next time. Alright. With a knife blade, you can kind of scrape it. There's a lot of solder left on this piece. Just trying to get as much of this off as we reasonably can. Trying not to hit the other cases of parts. That didn't really work. I'm going to put some flux on this. Nasty flux, but we got to do it. Nice, much cleaner. Well, that worked great. Okay, so copper braid plus flux is a nice little mop. Took a little bit of the solder mask with me. Damn. That's okay. Not really much you can do about that. A small price to pay for a working board. Okay, so we can put this resistor back on. But the rest will leave all of the MOSFET pads unpopulated for today. So glad I fucking tried the I'm so glad I tried the MOSFET before putting all of them in place. That would have been a huge pain to deal with. Having to take them all off with everything else on the board. That would have been no fun. Give myself a little bit of an angle on this one. So, I guess, let's just do all of the resistors. Do I want to do the resistors first or the diodes first? The diodes are harder. Let's do the diodes. So, where am I? Where is my cursor? Over there. So who is in place right now? R9. First place. D1. First place. Okay, so let's go back to group mode. All of the diodes. Wait, that's not true that they're okay. Oh, it's partially. I see. So, all right. Yeah, that's what I want the arrow key to do. I can scroll this around. Okay, cool. Alright, so let's just plow, dudes. This will be faster because I'm just doing one pad at a time. Four. Five. It's pretty much all of the diodes. So if we'll go there, this will go first. And then 4 up here. Hit it with my hat. LOL. D12. D6. E13. And so now we're going to do the shuffle technique. We solder. Where are we? E2. Yep. So you drop it in place, heat the pad with the lump on it. And slide the leg into the molten solder. Where is the line? I think it's the other way. Drag it into place, make sure that other leg is on the pad. Boom. Now we do that a bunch more times. I'm just gonna open this thing. Got a smattering of diodes now. I can just grab them off the board. And so these are leftover. Only component for this project I didn't have to order separately. These are left over from another fan driver project, actually. I use these as flyback diodes pretty much wherever you think that would be needed. Even though I know there's some smarts inside of the fans nowadays, still a big ass inductive load somewhere in there. So I'd rather be safe than sorry. And thus flyback diodes. And they're cheap, easy to place. Just a little added security. Like I've said a few times during the development of this whole project, I would love to install this in the rack and literally never think about it again. Obviously, that's not going to be... oops, my mic isn't really pointed at me. Obviously, that's not going to... it's not a guarantee. And I'm going to have to write some software that's going to be relatively easy, but I would love to be able to have this for like 5-10 years. The hardware for this. I don't think, unless life dramatically changes, the rack that I have now, the one that I've been building off of, should be totally fine for a long time. And even if I do outgrow it, if I like end up needing more servers or having more space, I'm probably gonna always have this rack as like the studio rack, just because it's a really manageable size and it's got a beautiful CAD model that it came with for free, and I've just generally enjoyed working with it. So there's very low likelihood And this is why I took up the project, right? There's if I was like, oh yeah, this is gonna be like have this rack for a couple years and then upgrade. No, I'm gonna have this thing for a while. More diodes out of the diode binder. How many more do I need? One, two, three, four. Yeah. We got four more. And I've got some on that pad. Not really a big deal. Get off of there. Oops. These should not be connected. I actually think they are electrically connected. No, they're not. Let's clean this up a little bit of flux. Okay, nice. Definitely not connected. I'll clean that up when I finish this component for the rest of the placements. Yeah, so in the spirit of, what was I saying? Oh yeah, so in the spirit of not wanting to touch this for the long time, that's why I did the transient voltage suppressive diodes as well. The flyback diodes probably aren't technically necessary, but for a longevity sort of, you know, and the MOSFETs have a body diode, I know, but for the longevity of the project, I think it makes sense. Wow, this is really not wanting to solder. Interesting. I'm going to put more on the pad. It's a lot more now. Ah, crap. I think I might need to switch. There we go. Straighten that up. I might be getting tired. The old fine motor skills, not really motoring. Okay, there we go. That worked. Keep hitting the other pad. I placed them too close. Oh, wrong way, wrong way, wrong way. Chat. Dropped it and it flipped around. Okay. Shorted it out. Back in the building, bro. He's back. Yo, dude. Goddamn. He made it. We assembling, dude. Good to see you. I know, you were an uncertified electrician. I saw your Discord. I saw the message. Bruffa. I saw it. I'm paying attention. What's going on? We got assembly day, part 1. The MOSFET that we selected, the output MOSFET for the fans, the drive voltage was too high. I misread the data sheet. And so it didn't turn on at 3.3 volts. I might switch soldering tips. This is messy. I'm going to switch to a finer tip. But yeah, the MOSFET that we landed on didn't work. I built one up in the circuit. And it didn't work. I tried it out with the function generator. Wouldn't turn on. Bumped the peak-to-peak voltage. to like 12. Turned on no problem. Full fan control. No issue. Oh, I just dropped that. Yikes. That little metal piece seems important. But we caught it at least. Oh, no, that's right. That's the inside of that one. But we got... I'll order more of the... I found another part that worked. And we'll get there. But almost disaster. Alright, we got a different tip now. A little bit finer. Let's see if I can make fewer of those accidental pad mistakes. D5. Let's see how we do at D5. Oh, I'm on the wrong. Jesus. Just did D4. But other than that, the stream has just been assembly mode. Ugh, this one is kind of sucking as well. I have these like aftermarket tips. I'm gonna try the factory one.
Zeus, the greatest god of all times, declare that you have offensed our sacred community.
Yeah. It's gone pretty well so far, though. I mean, actually, am I being honest with myself? Not quite. It's gone okay. But I'm glad I tried the MOSFET out, one of the channels out, before soldering them all in place. Because having to extract all of them with the rest of the components on would have truly been nightmarish. Doable, but probably just as efficient and time-wise to just like stand up another copy of the board. So I'm glad I tested it. There are benefits to self-doubt. Some tips wouldn't work with that screw-type soldering iron. Yeah. It's the FX888D. Yeah, this one's working a lot better. Boom. Is that it? Is D1 already soldered? Yes, it is. Okay. Oh, I forgot to do this cluster up here. D11. Little flux left over from that accidental bridge. Yeah. Shorted out. What soldering iron do you have? But you have a couple. Do you have a Hako? Alright, chilling. Let's do the resistors now. Not a branded one. Yeah. Is it good? Whatever one you do have? Or are you trying to upgrade? Alright, let's see. We gotta do... Okay, so let me mark all of these as placed. So the... grouping thing. Okay, yeah. So these are all done. Yeah, so this is incorrect. No, yeah, I'm gonna. These are source, but I'm gonna just say that one is placed. So it's. Wow, there's a lot of these things. So it's all of the MOSFET ones. It's basically all of the pull up or down resistors in the whole thing. All right, so we got to make tracks. We got some ground to cover here. All right, so let's start with R10. So if I haven't shown good enough, but the fine tip wouldn't get enough thermal mass. Yeah, I've been there. So this is, for people who haven't been following along, this thing in the bottom left, this is a KiCad plugin that lets you, so this is like my KiCad instance. This plugin is called Generate HTML Bomb. It creates a HTML like website you can go through and like, it's like a assembly guide, like an interactive assembly guide for your board in KiCad. No earthing pin on the AC side, for the soldering iron. But this is mad useful if you weren't aware of the Generate HTML Bomb plugin. It lets you like go through, like this is like an interactive fucking map of your board. So you can like go through like, oh, like what's this? And it'll like show you the component. And right now it's like, all right, I'm gonna go do all the 10K ohm resistors. Like let's go find all the 10K ohm resistors, and then you go find your component from your bins or whatever, and then you place them. So I got my resistors. I'm just gonna, these are all the 10K ohm quarter watt 0805s. I'm just gonna put a bunch of these on the board and go from there. Indian, I should gamble my life with electricity without safety. Yeah, but you're the uncertified electrician, dude. You're the shorted it out god. You could survive. Alright, so what we're gonna do first is just tin the pad. This is my technique. This is my no hot plate, no solder paste technique. You do one pad, you get your component nearby. Oh, do I have to? Orientation doesn't matter, but let's be able to read it. And then you melt the pad, slide it into place. That's the technique. I think I just made a pretty big point though. Get a little more thermal mass into there. I can cleanly get off. Nice. That's the technique. So then just go through all the parts, all the resistors, do the left pad, and then you can just physically flip the board and then solder all the right pads. This works for me. This is how I get down. Boom. 11. Yeah, the HTML, generate HTML bomb plugin is mad good. Mad useful. $13. How many resistors are there? There's 21, man. I'm glad I reused the part a bunch, but it's a little annoying. That's not annoying. Just a lot. Mountain to climb. Long run ahead. $20 and $5 down in that corner are also what we want. Okay, so this is one of the ones I goofed up earlier. So I'm going to flip the board for this one. So I don't want to be able to read this. Ooh. This to be upside down. Doesn't matter at all. Thank you. Surface tension. So these are the pull downs for the NMOS outputs for the gate voltage driving the NMOS. So this will guarantee that when the BeagleBone is rebooting or whatever, and the outputs of the BeagleBone GPIO are floating, these will ensure that the MOSFETs are off. Which is somewhat important, but honestly, would not be the end of the world if they turned on while the BeagleBone was off. Because the GPIO can definitely do an internal pull down. But just during the reboot condition, you never know. Which is what these guys are for. Yeah, I need a little more thermal mass to get that to sit right. There we go, bang. We got 6 and 7. I'm working my way through visually in that diagram in the lower left just to check out this video out and you're free. Dude, I'll put that in the break time queue. What's the video? Yep, so these are not pull downs or pull ups. These two are for, actually these are pull ups. These are for the other half of the temperature sensor, analog thermistor voltage dividers. So you can see the trace here coming in from the connector, and then this goes high, and then this voltage goes to the GPIO on the BeagleBone. So this is a voltage divider. A teeny weeny voltage divider. Pick and place machine with open source software called OpenPNP. Damn! I'm an open source PNP, dude. Actually, I'm not open source. Actually, they did sequence the human genome. I'm a human being. I'm kind of open source pick and place machine. A little bit. At least I have something in common with open place pick and place machine. Alright, I just exhausted my resistors. I have to get more. Did you, shorted it out? Did you see the, have you seen the Lumen PNP? Is that what the video is? I wish I had the money and space to cop one of those. I heard of it, yeah. It's similar idea. I think it's pretty small potatoes though. If that one's bigger. I would just want, if I was dedicating the lab space to a pick and place machine, I would, the killer app for me is dual-sided boards. And I'm sure it can do it. But like I'd want to be able to glue components in place and do dual-sided boards. Cause that's the thing. Like with your JLC PCBs and your PCB way, and you start to really accrue financial damage with dual-sided boards. Although I don't really know. I might be doing some misinfo right now. Probably can do. Lumen probably can do it. They can probably do stuff other than just place components. They probably can do paste and whatnot. I used a hot clothing iron. Yeah, you told me. That's epic, bro. Yeah, you told that story. I mean, that's a genius idea. Sometimes you gotta get down. Necessity is the mother of invention. Oh, what the? Needs more thermal mass. There we go. Yeah. I wish I could do dual side. I wish I had access to dual sided PCBA for cheap. That would be sick. That would be really cool. Typically what they'll do, I was looking into this recently. There's a bunch of different ways you can do it. Come on, get off. I got flux on this thing. Now I have a resistor stuck to me. I'm gonna clean this tip really fast. Typically what they do, I use a servo stabilizer for my home. For what? What are you stabilizing? That's sick. I don't have that. So typically what they'll do for dual-sided PCBA is for PCB assembly where you can like have the factory assemble your boards like every other, like pretty much the majority of circuit boards in existence were made in a factory, not by a guy crouched over a soldering iron. But what they'll do is they'll put a little, for when they flip the board, so they place the components, or they do solder paste with a laser cut piece of metal to squeegee everything in place. And then they'll either reflow it or sometimes, well, I'm kind of talking out of my ass. I don't know a ton about this, but I know they use glue. They use like a little glue dispenser sometimes to get everything working, to get everything held in place. So when you flip the board upside down, it guarantees the components aren't going to fall off, and then the glue gets removed during the cleaning process. That might be the way you would do, or like, that would be a killer feature to have, like a good, robust adhesive for something like a lumen or like a home pick and place. So how many more do I need? A lot. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's start with 5. Ooh, to stabilize electricity. Cool. Dude, I had a post kind of go viral on Reddit yesterday. I'll link it in a sec. Let me do after these, but a dude I was joking around that I was posting about the AI server. Anyone in here from Reddit, from the AI server post? Anyways, there was a dude in the comments because I was lamenting the fact that I've popped breakers in this room because I got like the 3D printer going and I got my workstation going, and then I had this AI thing going, consuming a lot of power. The guy was like, just switch to 240. I was like, what? It's like, okay, maybe you could maybe there's some way you can, I don't know what I thought. Maybe there's some sort of a step-up transformer that somehow is gonna multiply the voltage without adding additional. I don't know what I thought. Maybe there's some dark discipline. So I asked the guy, like, what are you talking about? And he's like, get an electrician to come to your house. I know. He's like, get an electrician to come to your house, and for the one sub circuit in your house, have them boost the voltage to 240 by like. I was like, okay, bro. Okay. I'm not gonna do that. I fucking live in an apartment. I don't own this place. I can't have an electricians come over and get freaky with it. That would be sick. Oh man. Okay, wait, no, nice. All right, so it's R2, R4. Yeah, so all these ones over here, basically. Yeah, I thought that was funny though. Maybe to him, it's nothing. It's nothing to have a guy come and completely destroy the wiring of your house. Maybe he's done it. Maybe he's braver than me. That would not fly where I'm from though, sadly. I sent a picture of the stabilizer in Discord. Hell yeah. Wait, I might have to... I'm gonna come check out your video. I'm gonna stand up, stretch my legs, and check out these links. And you'd be a smart electrician to not do that. Let me check out this video. But the Lumen guys, it's a YouTuber. It's like a YouTuber's project. Okay, add. Whoa. Yeah, it's a lumen. It's a lumen. It's a lumen. It's a lumen. Yeah, this is the lumen. This is a lumen. This is the thing I was talking about. Damn, the pink is clean. The pink prints with the black, with the freaking black aluminum extrusions. That's a gong. Yeah, this is awesome. Nice.
偏僻的监控面板，还有视频的灯，然后lumen偏僻的原作者有序的移动，将 X 轴和
Dude, you're on China, dude. Shorted it out. You're on Chinese YouTube? You're on Chinese YouTube with it? That's fucking sick. Oh my god. Is this what I think it is? Yeah, I'm legit. I'm about to subscribe. This guy's sick. Bro, he played. Oh, he left. He left. He left. He left. He's watching Apex. He left. He left the Apex in. He left it. Recommend. I mean, China's my neighbor. Yeah, but do you speak Chinese? He's watching Apex Legends, bro. He's watching ALGS. It's a nice wig. I know these guys. No, yeah. He's got English subtitles. That's so funny he left it in. Respect. Big respect. Yeah, see, this is how normal people do it. Normal people are... I gotta get on this method, bro. Place all his components, solder it in place, bang. Oh, what's that? Oh, he's got the auto screwdriver. Yeah, I'm subscribing to this guy. Shorted it out, putting me on. Putting me on. So cool. Love gauges. Everybody loves gauges. All right, let me check out your Discord. Discord. Whoa, what is that? 2 kiloamp servo stabilizer. Wow. How does it work? Wow, this is cool. I'm not set up to be able to show this, but this is cool. My father's friend made that from scratch. That's so cool. This was the post. My post that I was talking about. Okay, let's get back to soldering. That's so cool. I don't understand what it does. Is it like a power conditioner? All right. Back to solder. He runs a shop, stabilizes fluctuations. That's really cool. Do you know like the operating theory? I guess I don't really have to deal with that, so I don't know what that would be. Where am I in microscope land? I'm up here. Okay. Bang. Then we got the 17, 18, 19. These guys. Am I out of resistors on here already? I am. Who designed this, dude? Oh, wait. 1, 2, 3, 4, 5. You should ask your dad's friend how that works. That's really cool. Actually, I guess I have a UPS. I have like a battery backup thing in the server rack, which pretty much does the whole room. That probably has some power conditioning built into it. And of course surge protectors, but I think those are just passive, not active. I was in HomeLab Discord server, nice. Dude, honestly, Discord is, I'm still trying to, I'm new to the freaking content game, dude. I'm not super up on my cord. I gotta get in on mad Discords. Only in a few right now. $17, $18, $19, and then 1 and 3. And then I think that's it for the 10Ks, but we have to go back and solder all the other legs on, which is not that big of a deal. Like I said, this is a chill out solder stream. Now it's chill out. Earlier we were stressing, but we're chilling now. Freaking gate voltage, dude. Can't be backwards. Literally can't even see the writing on it without the microscope. But gotta be right. Okay. So let's go back through and solder the other halves of these resistors. Skip that one for now to not spin the board. Alright, we're flying around now. Finding 10Ks and finishing their circuits. That goes the other way. This guy's not soldered. So I guess we'll flip. Go do this one in the corner. Clean that diode up while I'm over here. Okay. Any other this direction? Yes, this one. R26. You can get all of the grid of them up here. So this is the this is the filter network for the tachometers. These are it's a filter. It's basically a low pass filter for the tachometer output from the fans. I don't know if you've ever looked at, probably not, but if you ever looked at the output from like a PC fan tachometer, it's a mess. I would love to do a blog post about this, and I think I eventually will, because it is all over the place typically. So the idea is that inside the fan, there's like a switch that's closing twice per revolution, and the idea is that you pull the other end of the switch high through a weak pull-up, and then have the switch pull your signal to ground, and you just look for falling edges. But that's like the theory, but in practice, there's like a bunch of other junk on the waveform, typically, in my experience, which makes it kind of hard to do reliable measurements of the tachometer fans. And you know, it's one of those things, problems have been solved in industry. Everybody knows how to deal with it. But if you're trying to get, I don't know. I was just surprised at how much of a mess it was. Okay, and I think that is all of the 10K resistors. I think that's everybody. Let me look. All these. Looks good, looks good, looks good. Looks good. Looks good, looks good. You're fine. You're fine. You're fine. You're fine. And then this 5 up here. 1, 2, 3, 4, 5. Yeah, I think we're good. Okay, so let's get back over here. Oh, whoops. I am on totally the wrong screen to interact with that. I think so, yeah. It's got to be due to the inductor, right? I'll show you it in a future stream. So there's supposed to be 21. Let me just count these really quick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Count it again. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. What is this guy up here? Is this guy a resistor? Ah! Ah! What are you? Ah, it is that one. R25. You bastard. Okay. I think it's got something to do with the inductance. But if you have a really fast micro, and it's like a, there's a bunch of high frequency stuff. There's a bunch of like weird on the high side of the waveform. So like as it's being pulled back up by your internal resistor, it's like pretty jagged going back up. I have no idea why. And it also depends on the fan, but if it looks like jagged on the way up. So if your microcontroller can read it more than once, which is really bad. I think your fan's spinning when it's not, or spinning much faster than it actually is. Time will tell though how relevant that actually is for this project, if we're even going to touch the tachometers. I decided to, they're there, and even though we don't have the RPM for the other modules, if we can get like a voltage to RPM relationship for this module, we can like kind of model it onto the other ones and do it that way. But I don't have any immediate plans to integrate RPM as like other than just like a logging thing. Like it might be good to just have that status somewhere on some dashboard to be like, oh yeah, our fans are wildly oscillating. Yeah, that's the idea. So there's a low pass. That's what the all this stuff up here. So this whole block of resistors and capacitors is it's 3 low pass filters for the 3 tachometers. Yeah, so the tachometer right here, for example, tach 2. Follow this, pulled the ground, and then, that's actually pulled high. So this is pull up, and then this is a low pass filter. That's the idea. All right, so now we're chilling on the 10K ohm resistors. I've been live for 4 hours and 30 minutes. I think I'm gonna keep chugging for a little bit. I'm in a good mood. Yeah, but it's just an interesting artifact I've noticed. All right, so let's just keep going on resistors. So next we have the 422 kilo ohm. So let's go find this. I got my box of DigiKey. Got the resistors. Easy. So who is this? Yeah, that's the other. So speaking of the filter, it's these guys. 14, 15, and 16. Well, well, well. Same exact footprint. Me. 14, 15, 16. Kind of scattered the components a lot over here. Whoops. Okay. Boom. So now we flip the board. Rotate the board. I'm lost. There it is. And then do the other sides. So these are the resistor part of the low pass filter. Bang. 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 Skinny little traces on either side. Solder up. No problem. Alright. Sourced. Placed. Nice. Okay, now we got the big fun LED resistors. The half watt that I had that are a little too big. 66.5 ohms. Maybe I ordered more. I did order more. Psych, even though I had them, I ordered more. These resistors, whoa, earthquake. These resistors are definitely oversized. And they have to dissipate almost no power. But it's a fun little package. So, yeah, it's those three. So, feel the tape. Need 3. I used the same LED color for the 3 indicators for the project. We got 3 LEDs, run, web, and fault. Does anyone want to guess what my plans for these are? I think I'm going to have run, turn on, because there's going to be a certain number of lights on the beagle bone just by virtue of it getting power. But I think I'm going to have run turn on as soon as possible in the boot process. So I'll probably make this a systemd service that requires nothing. So this will turn the LED on or maybe blink it at a certain period. Right when the... Oh wait, I'm doing this wrong. Right when the thing turns on. Right when the beagle bone turns on. Web will probably be solid most of the time, and then when someone is interacting with it on the web interface, it'll probably blink, just like your HDD LED on your computer. So like whenever anyone's tooling around in the web interface, it'll probably blink. And then fault will probably illuminate solidly if there's, oh Jesus, sorry, if there's any problems. Like if the web interface crashes, or fault will be like an active fault in the system. Probably pretty forgiving, because I don't want it to turn on unless a human being needs to do something. Like if it's detected that I don't know, something's wrong, it'll probably, like if it's too hot, for example, that'll probably get surfaced via the web interface. But if there's something physically wrong with the board, or it like detects that the fans aren't spinning, or like something goes wrong in the boot process, fault will turn on then. Where it's like, okay, I've given up the ghost a little bit, and now I need somebody to come fix me. That'll be the idea with those LEDs. But because, I mean, it's gonna have a web GUI. Like it's a little bit wasteful to put LEDs on it. But I mean, the design has already had problems so far, so might as well have as much debugging as I can get. Wow, those soldered up really nicely. Let me rotate the board. Okay. Mark them placed. Sourced. Placed. Ah, the TVS diodes. That is who is next. There are 13 of them. There are 13 TVS diodes. And I think we go for it. Pretty easy pad. I mean, it's pretty much the same pad as the other diode. But that might be... We'll see. We'll see how I feel. Yes, located. Okay, so let's just pray. I've never used this part before. Let's pray that they have a sensible marking. You try to discover these things by reading the data sheet, and it just doesn't always translate. Because if it doesn't, we have to go look at the data sheet to see the tape orientation. Oh, yeah. Dude. There you go. Easy. Okay. Let's start down here. So 1, 2, 3, 4, 5. So there's 6 down here, so I'll get 6 out. Oh, I already dropped one. That's so funny. Oh, there it is. I see it on the bench. Nice. 2, 3, 4, 5, 6. Freaking jumping around. Where the board is getting kind of loose in the vise, I'm going to give it a little bit more crank. There's D1 or D21. The line lines up with the line. Okay, let's get into it. Time to solder 13 freaking diodes. This song is so good. It's just what I need to do. This is a little battery. Ooh, oh man, this guy's got skinny little legs, bro. Damn. Oh. Eh. Okay. Not bad. Electrically fine, but aesthetically. Although, look how small. Look at the wide angle tells the truth. This stuff is so small. But at my pride, if something is tiny and bad, it's still bad. Sadly. Oh, that actually works great. So, piecing it a little bit at the end. Okay, so then, move this. Actually, I haven't checked these. Let's just be totally sure. Oh. Okay, I just massacred one. I just massacred this one. Take it out of the circuit. There's nothing there, though. Okay, yeah, I'll just grab one out of the circuit. Beeping. Oh, there it goes. Okay, nice. All right, yeah. So it's the right. Oof. Okay. Good call checking it out of circuit. Is nothing there though. All right, I massacred one diode. Sorry, one diode. You were sacrificed for no real reason. These are the Transient Voltage Suppression TVS diodes. And the idea is that for all of the pins that control quote unquote high voltage, so for us 12 and up, so for all of those pins that kind of leave the circuit, like go to the modules, the GPIO is protected with these, and it gives yes, it gives everything a short path to ground, but transient voltage suppression. A chatter recommended I install these. Thank you to bro, I forget your name. If you're here, what's up? But the circuit will work without them. So if we run into problems, I will just remove them from the design. Oh, this is going bad. Oh no, we're chilling. Okay. Need more. 2 more. P26. Out of the way. Oh, they're gone. I see one. I'll put some stank on that other one though. That's gone. That's on the floor forever. Pour one out for that diode. Goodbye. Will remain in my carpet until I move or vacuum. SMD live reaction. Yes. I need the soundboard over here. Actually, no, I need to be doing less over here. Soundboard would be funny for SMD. We should make AI soundboard that watches the stream and auto soundboards. That would definitely not go bad. That would work the first time and be great, I bet. This was one of the harder pins in the design, I remember. See this? Oh no, it's not this one. One of the ones over here, like this diode, is a little funky in terms of going under the board, etc. Slightly funky. Oh, I dropped the parts on the... They're sealed, they're okay. Okay. What is your marking? Okay, you gotta rotate. It's funny to see the labeling like move around diode to diode. See how far to the left this is? It's interesting. Okay, so we got 1, 2, 3, 4, 5, 6, those bottom 6 in place. So let's flip them and do the other legs. Could be a little bit better focused. Yep. A little sharper. You can kind of see it on the wide angle, but the microscope setup here is a little bit less than ideal, to be honest. I'd probably do like 10 PCBs a year, like max 10 assembled a year. So it's really not something I do often enough to like justify buying a bunch of gear. But over the years, I don't know, you accumulate some stuff, you see something on eBay you want, you go for it. So I can definitely do it. Like I have the tools to be able to work through it. But if I'm not doing that much SMD assembly, I'm not doing that much filmed SMD assembly by extension. So could be better, but you know, everything else you live and you grow and work on more stuff and invest in your gear and practice, etc. All right, so we got 7 more, all up in the corner. Another kind of a sin of this design of these diodes up here. Could be cleaner. I'm gonna just tab all of these right now. Three, 4, 5. 5, 6, 7. 7 diodes. 1, 2, 3, 4, 5, 6, 7. Okay. When do we assemble? I guess the AB on this one is to the left as well. So maybe it's not a manufacturing variability. It makes sense as those look like I believe they look like laser. They look like fiber source laser markings. The material ablated and removed. Trying to get a multimeter that can output the readings on OBS. Yeah, that would be awesome. There's a dude in here that has a YouTube channel, or a guy that's come into the chat a few times that did a really good job. Because the issue though with that, with getting the multimeter readings into OBS, as a viewer, it's kind of hard to tell that, like, oh, that's a multimeter, right? You just see, like, moving number. Like, it doesn't have the physicality of, like, the piece of gear. But, I mean, you could definitely make something happen. And if you're direct about, like, okay, yeah, that's the multimeter, or, like, you label it as such, people will get there. But I feel like visually, you're kind of giving yourself a little bit more to do by not using the physicality of the meter, because people see test equipment and they kind of, at least anyone that's watching this or would be watching other electronic stuff, like you see the test equipment and then you like, okay, yeah, multimeter, oscilloscope, soldering iron, like there's the visual signature to the item that would help, you know, that is doing, it's doing work for you. It is telling your audience, yes, this is what I am. Instead of you having to do it yourself. They make, they do make like USB scopes that are pretty cool. They make like really fancy schmancy ones. I had a boss that had an amazing one time. It had a really loud fan though. You could definitely use something like that, and I'm sure those are a dime a dozen used. I don't know the the model names off the top of my head, but like this one. Shrewsbury or something like that, yeah. I'll check that link out in a sec after I finish up these diodes. Okay, boom. Gotta do the other sides. Joint doesn't look very good. I'm gonna clean that up right now. Other side, this one doesn't look very good. Which one was that? Innocent, yeah. Yeah, maybe it's just the camera. Oh, weird. Huh. There we go. Okay. Woo! All right, let's go check out this oscilloscope. Wait, let me just mark these guys are all placed. Damn, there's 3 more SMD parts in the design. I'm going for it. All right, let me check out this multimeter. We've been live for 5 hours, boys. I'm pulling it up. I'm pulling it up. Dude, new Baja subs at Chipotle? Oh, I mean Subway. I'm getting hit with an ad. We gotta look at resistors, or transistors. I need ad block on this setup. Oh, see, that's pretty cool. That's pretty cool. But it's not first party. Suitable PC videos. Hi, this is awesome. Yeah. I guess that could be cool. You could do like a in OBS, you could do like a virtual gear rack thing. All right, let's finish this. We got three more SMD parts. I've been live for a very long time. Let's do this. All right, so it's the 100 PF capacitor. C1, C2, C3. I can do it. Here we go. Oh, wait, I didn't bag this. There's one more TVS diode here. Yeah, putting that back. Okay. And the LEDs, too. Might as well do the rest of it. 1, 2, 3. 6 more components. I can do 6 more components. This is the other half of the low pass filter that we've talked about a few times. Oh, 0805 is totally hand solderable by me. I've done 0603. I've done 0402. I did not like doing 0402. And I remember that. I don't remember if I had as much of a problem with 0603, which probably means I didn't. But 0402 is that's pretty small. You can do it. Just don't drink coffee that day, and your life will be much easier. I'm gonna have to go back and stay. Ah, fuck. All right. Boom. These guys are absorbing a lot of heat, though. Solder's not coming away from them very easily. Bring that up a bit. Okay. We got diodes. We got the LEDs. And then we're LED done. Green diffused LEDs. We need scissors. Mm-hmm. Ooh, jeez. I think you just get a little... Ooh, I just picked up a TVS diode. Hopefully it didn't fall off the circuit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yep. Alright. Whoops. I think these guys have arrows underneath them to... Oh, I dropped it already. I think they have little arrows. Yeah, that's a small LED, bro. Oh, it's so tiny. Oh. Yeah. Yeah. I think it's... Let me just check if this is ground. Yep. Okay. So current's going that way. So let me throw... solder on that. We gotta be mad careful to not flip it too much. Oh. Alright, happy enough with that. We can go back and clean that up in a sec. Sneeze once and it's gone. Ain't that the truth? Yeah, that is tiny. That's a pretty small LEDs, boss. 2, 3. That's pretty small. I'm gonna test these with the power supply too. Just to make sure. Oh, I dropped one. Oh, I see it. Holy shit. I didn't lose it. Just the green side is the side we want. That song is crazy. A little too much. Maybe a little too much for the playlist, honestly. A little too crazy. Alright, bang. Alright. Now we spin. One. Two. I don't know if that's soldered. We can test it though. Yeah, these are easily the smallest components in the design. Okay. Let's give this a test. So... Get my 2 probes. So they're supposed to be driven. Drop that. Ready? 3.3 volts. I'm going to turn the current pretty much off. Okay, here we go. Nice. Check that out. Man, that's cool. Oh. Okay. All right, chat. Yeah, I think it looks good. I think it's an attractive color. I'm not really one way or the other about it, to be honest. But I think it looks good. Yeah, whatever. I got red ones and matching LEDs or matching resistors. But if I want to switch it, but I like the green. I think it's pleasant. I think it's very networking hardware. Yeah. Okay. This has been a marathon. This has been a big one. 5 hours. That was good. This is where we're at. This is where we're at. Got this tested, all the passives in place. Need to order more MOSFETs. So next time will be the MOSFETs and then all of the through-hole stuff. But making progress. Wait, I got the beagle bone to show you. This is how it's gonna sit on the beagle bone. With headers, of course, but yeah, making progress. Making progress, man. Climbing up the hill. Next stream's next Tuesday. Same time next week, dude. Same time every week. Unless I get sick or something. But yeah, Tuesdays, 6 p.m. Eastern. Yeah. That's it for me. Bro, shorted it out. It's Wednesday for me. I'm sorry about that. Oh, that's right. Time difference. Wednesdays, if you're in India. Yeah. So good to talk to you. Ask your father's friend about how the power conditioner works. That's really interesting. I'd be interested in trying to understand like what the theory is. That's really cool. I've never seen a component like that in my life. Yeah. Cool though. That's it for me. Have a nice night, everybody. Thank you for watching. As always, I'll see you next week.